What's going on, everyone? This is Future J from the editing. I just wanted to let you guys know that this is a new thing. This is completely new. Never tried this before, and I've never even had this phone mic. This is completely 100% new, and I apologize. Now, I also apologize for the phone stand that I'm using as it wobbles everywhere. Every time I move, it seems to wobble. So, I shall send you back to present J with this information. Thank you very much. See you later. What we are looking to cover during the first exam of chemistry. This is a paper taken from a couple of years ago, made by the University of Leicester. So all the questions that are made by all of the chemistry lecturers. So thank you for doing that. This is the foundation year paper. Foundation year paper worth 100 marks. So, question 1. A photon has a frequency of 8.1 times 10 to the 15 hertz. We need to find the wavelength of this photon. This is the physics side of chemistry. So, if we take our white book, as here, we have been given the frequency of F. So F is equal to 8.11 times 10 to the 15. We are looking to find our wavelength. I'm using a new stand, so it's going to be a little bit bouncy. I do apologize in advance. So to do this, we need to find an equation that links our wavelength and our frequency. And to do so, we can do one of two things. We can either remember it as C equals lambda F, or we can go to our revision note sheet, as that's what you get on the foundation year, and you can see if you've written it on there. So, subbing it in, C is the speed of light, or the speed of a wave, which comes to 3 times 10 to the 8, also given on periodic table of elements and data sheet. This is the same value throughout physics and throughout chemistry. So when doing these foundational physics and paper marks, you can just use C is equal to 3 times 10 to the 8. So 3 times 10 to the 8 is equal to our wavelength times by 8.11 times 10 to the 15. So we can now grab our fully functioning calculator. I'll just do it up here. We're going to go onto our calculate mode, and we're going to type in so we can't just input this whole thing into our calculator. I've missed a bit. We have to rearrange to find this. So after rearranging by dividing by 8.1 to the 15, we get 3 times 10 to the 8, you can't see, divided by 8.11 times 10 to the 15, and that equals our wavelength. And our wavelength is then equal to once I figure out how to use my calculator. You get this, 3.699 times 10 to the minus 8. For this question, it hasn't stated to change it into an actual thing. So obviously 3 to the minus 8 meters is very, very small. So if we were asked to change this into a valuable number, we could change this into these units by just dividing by 10, or just timesing by 10 to the 6 to give us 0.03699. But for this question, because it says we don't have to specify, we can just leave it in meters. So the second part of this question, in what region of the magnetic spectrum would this be found? So this is just a memory question. So we are looking at our frequency here, 8.11 times 10 to the 15, as given in the question. Second part to this question is, as you can see, in what region of the electromagnetic spectrum would this be found? So this is where we turn to our frequency, and we have a look on our spectrum where visible light is somewhere in the middle. And this is between times 10 to the 14 and times 10 to the 15, which is where we are at. So this would be visible light, just because of obviously how much the wavelength, the frequency is, and as that's what the scale produces. So that would be the answer to the second question, giving us 1 mark. Oh, I've just hit my camera again, damn it. Third question states, calculate the energy of a mole of photons associated with this frequency. So for this equation, we are going to need to use our frequency here. So we're going to use the energy equation. Where E equals H times our frequency. Now we could either use this equation, that looks relatively simple, or we could use E equals H times C over our wavelength. So we could use either of these values to calculate our energy. I'm going to stick with the top equation here, simply because I don't want to work in a fraction, and if our wavelength is wrong from the second part of this question, it means we won't lose a mark for using an incorrect wavelength. So it's just a heads up, you can use both. We're going to take the top equation, where E equals H times F, and we will substitute in values for H and F, where H is our, what's that called? I don't actually remember what that constant's called. Let me have a look. Planck. H is our Planck's constant. So our Planck's constant is 6.626 times 10 to the minus 34. We're going to times that by our frequency, 8.11, times 10 to the 15, and that will give us our energy. So that value should be equal to 5.3736 times 10 to the minus 18. Oh God, my 8. And then because the question states we want 1 mole of photons, so this is just the mole, this is just the energy of 1 photon. We want to find the energy of a mole, so we need to use a constant called Avogadro's constant, which is 6.02 times 10 to the 23, to find out what a mole of photons are. Ah, that works. I've run out of space on my whiteboard, but you understand what I mean. So we will take 5.3736 times 10 to the minus 18. We will times that by Avogadro's constant, 6.02 times 10 to the 23, to get the energy per mole. And that should give us 3,234,958, so 3,234,958.97 joules of energy per mole of photons. Now this question isn't fully finished because this isn't our standard unit for energy. Our standard unit of energy is kilojoules per mole. So all we need to do is turn joules to kilojoules, so we divide it by 1,000, which should give us 3,234,958. We'll go 959 to 3 dp. 3,234.959 kilojoules per mole. And that gives you 4 marks for everything that we've just done there. So for question 1, key equations and stuff you need to know would be reading and interpreting the question would be one of the biggest things. You need to know where in the question you can get your frequency, which is why I use one of these. So literally in the question I've highlighted what we're looking for. So we're looking for a photon and our frequency. So immediately I've gone, this and that automatically have to be linked. That's our frequency. So in my head I'm going, what equation links frequency? Well, immediately I'm thinking speed of light equals wavelength times frequency, and the question wants wavelength, so we can just simply throw this over here, giving us C over F equals lambda. First question, Bob's your uncle, 2 marks in the bag. So that's the first equation you need to learn. C equals lambda over F would be really handy, because then it unlocks the second question, well, actually the third part of this question, the energy of a mole. So you need to know the energy equation, E equals H F. You need to know how to manipulate the equation if necessary. I don't think you will do in most cases, because a lot of times examiners will want you to find your energy to then find the energy of a mole, or you want to find a substance for said substance. But most of the time they'll want you to find energy. But if you've been given energy, you automatically know your Planck's constant because it's given on the data sheet. All you need to do is manipulate the equation to find energy over Planck's. That gives you your frequency in meters. Not in meters, sorry, in hertz. For this question, question B, it is asking us to use the Beer-Lambert law. So this law here, to relate optical absorbance of a molecule to the concentration. Now below our equation there is a lot of text, so we'll just go through it slowly so we can digest and use all of our brain cells to uncover what we actually need. So what we need first is we need to find our absorbance. So that's at the wavelength of 542 nanometers and a concentration of 50 is this. So all of the highlighted stuff is exactly what we need. Now this is of oxygenated. You don't really need to know this, but it's helpful, I guess. But we can just take what we have and immediately throw them into the equation, which we will do. So on our whiteboards or our workbooks, we will write out the equation again. We will know what we will sub in what we know already. So we know our absorbance is 6.95 times 10 to the minus 4. We don't know what our E is. Well, we do. Our E is the molar absorption coefficient. Spelling. We know what our concentration is, which is 50, and our path length, which is what we didn't highlight actually. Our path length is 1. Now our path length matters what unit it's in. Normally we use centimeters for this equation, but all we do is, if it was in meters, is we would change our end unit to meters. So now all we need to do is find our molar absorbance coefficient. So we would divide this side by what's in the box. 6.95 times 10 to the minus 4 divided by 50, because 50 times 1 is the same as 50. And that gives us our E. Now E in this case is 1.39 times 10 to the minus 5. In the question, it says take care to include the correct units. Okay, so I believe I found where I have gone wrong. It took me a little bit of working out. So for A, I believe our units are centimeters to the minus 1, decimeters to the minus 3, because then looking at both, I'm actually just telling porcupines now. I do apologise. Moles per decimeter cubed per centimeter, because then our moles would cancel, our decimeter cubed would cancel, so then it would be moles centimeter minus 1 each, which then means we can go moles cm minus 1, which is the correct units. So again, just a quick one from future me. This way of finding out your units is very unreliable. That's just the reason I chose to do it, is so that I could walk through how I would logistically get to the units. But simply by looking into the next question, you will see that the units of your molar absorption coefficient are mole centimeters all to the minus 1. So if you just look ahead to the next question, you will see that there are units that fit both questions. If you are to do this, however, just be careful that you're working in the same units and everything for both questions are in the same units, because if they're not, then that makes things slightly more complicated. So because my dumb brain was talking over my explanation for this question, I'll go through it. So as shown on my whiteboard, I'm showing you that the path length is still 1, as we are assuming that the concentration and the path length are as the same as the first question. So we're writing it out again. So A equals our molar coefficient absorbent, which in the question was 10. And we are timesing that by the same concentration we had last question, so 50, and the same path length as last question, which is 1. So then we are going to times all of our values together, so 10 times 50 times 1 equals 500. As you can see here, I've not put any units, as this is because there was no units for absorbance in the first question, so we don't have any valid units for absorption in the second. Thank you for watching, and I will see you guys later.